Hey, welcome back. In the background you can see my new lathe. I decided to sell off my old Chinese lathe that I rebuilt, and I bought a Emco Maximat Super 11, which is a very nice high-end hobby lathe or low-end industrial machine. So I want to give you a quick rundown on the machine, what it is, what I'm going to do to it, what I already did, and so on. So let's get started. So I bought this machine off the German equivalent to Craigslist. It was described as very good condition, and that was the truth. When I arrived there where I bought it, it looked almost like new. It was partially took apart, but you already could see that it had almost no hours on it. It was almost new. The ways are completely undamaged. The bed is completely undamaged. The ways show no sign of wear. There are no impact marks on the compound or on the cross slab from the chuck jaws, so that's a good sign. The gear housing on the inside looked perfect. The gears were perfect. The spindle nose, I think the original chuck never came off this machine. At least it looked like it. So I decided to take it home with me, fit it in the back of my car without many problems. It's a little bit larger than my last lathe. My last lathe was 250 by 550 millimeters swing over bed and center distance. This one is 280 by 660, which is more than enough for me. Compared to my old lathe, the old lathe was belt drive spindle. This one is geared. It has a 3-phase motor down in the back. It goes with belt, poly V belt up to the gearbox, and with those two levers you can switch between all gearing ratios here. Original speeds range from 55 to 2200 RPM, which is a very decent range. Originally the machine came with a single phase 2-speed motor. Those run terrible rough. They do not run smooth. So I threw the single phase motor right away out, and I put in a 3-phase motor, 400 volt. And it runs off a VFD, so I can even choose speeds between those here. But I still have the advantage of the gearbox when I go in lower range, that I have incredible high torque. And it's very fast to change speeds that way. This lever here turns on and off the feed gearbox or reverses the direction of the feed. If you want to cut a left-hand thread, you go this direction. For normal threading and power feeding, you choose this setting. The feed gearbox down here, it allows, without changing any gears, it allows all the common metric pitches for threading here, from 0.25 up to 2.5 millimeters, and all feeds from 0.03 millimeters up to 0.3 millimeters. If I switch the one gear around in the back, I can do imperial threading from 96 threads per inch up to 2 threads per inch. It comes also with additional charts for threading. If you use additional gears, you can cut almost every metric and imperial pitched thread, plus module threads for warmth and diametrical pitch threads. So this is very well designed. For threading it uses an Acme screw here, and for power feeding it uses a drive shaft down here. It's a hex shaft and it drives the carriage via the rack and pinion drive on the inside. It's also used for power cross feed. My old lathe didn't have power cross feed, this one has, and I'm very happy about that. We'll show you that later. Spindle runs in two tapered roller bearings, precision version, P6 bearings, very substantial bearings for the size of machine. Very rigid headstock construction. Spindle is all hard, all ground. It has a short taper number 3. That's the same taper as on a camlock spindle, just without the camlock arrangement here. The chuck just gets put on and 3 nuts pull it tight against the spindle nose. It's a decent design. On the inside I have a mortise taper 4, which I'm very happy about because I can reduce a sleeve. This is mortise taper 4 on the outside, and on the inside it fits the Deckel 355E collets, which I use also on my deep-bit grinder. They go in here, this goes into the spindle. Then I have a draw tube from the back, which pulls the collet tightly into the spindle. And this allows to use collets very close to the headstock, very rigid. And the Deckel collets, if you buy the genuine ones, are very good quality. I only have a small number of these collets, but I will buy the full set, which starts at 0.5 and goes up to 16 or 17 millimeters in 0.5 millimeter increments. It still has a compound on it. The compound slide on this machine is decent. It's nothing to write home. Problem with every small lathe is that the compound is a weak point. Some might say that a compound on every lathe is a weak point. But it's well designed. The angle adjuster works well. You open 2 nuts here, and then you can swing it 360 degrees around. And the cross slide is T-slotted, so you can pull it off completely with just a few screws. Works well. I put my Trepan 111 on it, and I will keep it on it. The machine came with a multi-fix size A, and I sold that right away. Well, I like the multi-fix system because it works. It's very common here in Europe. I'm not a big fan of it because I cannot make my own inserts for it. This compound will go. I will make a solid tool post. I have to order a nice chunk of cast iron. I will machine a nice solid tool post with the option of dropping the compound slide in the back of the cross slide. Still having the solid tool post in front and then having a compound in the back, which works only for small diameter work up to maybe 50-60 millimeters, but that way I can do taper turning, short tapers, without having to remove my solid tool post here. Back here you can already see the X-axis linear scale. I took this off my old lathe. This is a 1 micron per division linear scale. Mounted it in the same spot as on my old lathe on the chuck side, which seems a little bit insane, but it has its advantages, especially when you wouldn't want to use the tailstock. If you mount the linear scale on this side, you lose a lot of travel on the tailstock. Plus there is a precision issue with mounting the linear scale on this side. Watch Robin Rensetti's video on his hard-inch HLVH, where he showed the positioning of his linear scales. The C-axis linear scale is classically behind the bed, mounted against the bed, and the reed head rides against the bed slide. That's standard construction. I'm already working on a design for a full sheet metal cover around the cross slide that also houses the linear scale against impacts, small arm fire, chips and dust. That's very important. I designed it with 1.5mm stainless steel. I will have that laser cut in and bent for me. I can't do that myself. Also, again, as on my last machine, the bed is covered with leather, black leather. This is 1.5mm cowl leather. And this just folds up within itself when you crank the cross slide over. I can move the cross slide over far enough to reach short pieces that are chucked in a collet. I already modified my important chucks to fit this machine. I can use my 6-jaw, my 5C collet chuck, and my magnetic chuck on this machine now. And it also came with a 3-jaw chuck. This is original Emco chuck with integral short taper mount, which goes on a spindle. It's a nice chuck. It's very short overhang, but it's only a 3-jaw and it's not adjustable. I'm not sure what I'm going to do. Maybe it will live on my rotary table or something like that. Since I have the 6-jaw, that's what I use all the time. I 3D printed a dummy cover here, because when you crank the cross slide in to do small diameter work, the dovetails in here are exposed, and I do not want to get fine chips and grit and stuff like that between my sliding surfaces. That just introduces additional wear. So I 3D printed this temporarily cover, which just slots into the open-ended T-slots here. This will go away once I have the sheet metal covers laser cut and fitted to the machine. The bed is hardened, it's ground very nicely, it has a very good finish on the ways. The machine also has a tailstock, which you probably... oh, it was all the time out of frame. Here's the tailstock, has 80mm travel, it's a hand crank one. Maybe I will do the modification to a rack and pinion again, but probably not, because I can use a drill chuck holder in the trepon and use the drill with the bed slide. That's the same effect as a rack and pinion tailstock. Morsepa 2, nothing special about the tailstock. It's substantially built, it's very, very heavy. And it's locked from above via this large screw handle here. No, that's okay. That's well done. This large stainless steel back wall here did not come with the lathe. In fact, the lathe didn't come with a stand or with a splash shield on the back. This is only temporarily there until I design and have a real back wall fabricated for this machine. But it will be probably stainless too. Has its advantages. I will build a frame out of Bosch aluminum extrusion, the T-slotted extrusion, and I will cover it up with stainless steel sheet metal. So let's come in a bit closer and look at some details. Oh, wait a second. Let's run this machine. This annoying noise you hear is the fan of the variable frequency drive. It's probably dying. The fan, not the VFD. So this is 200 RPM. This is 50 RPM. Let's go up 1100. I find the noise level of the machine very, very decent. It's absolutely okay for a geared machine. When we put it at 300 RPM, I can show you the feeds. The carriage has a lever here on the right side, which can be turned around for feeding in this direction. Or for power cross feed. Okay, better view at the carriage. This is the feed control, lengthwise feed, and if I turn it 180 degrees around, it's cross feed. This is the half nut lever for threading, and once this is engaged, the feed lever is locked, and vice versa. Once the power feed is engaged, you cannot engage the half nut, which makes sense, otherwise you would break something terribly. The screw for the power feed is not spinning at the moment because there is coupling in here. Which allows it to be disengaged if not in use. The power drive shaft down here is always turning. It's well built. It feels all very rigid, very nice engagement of the controls. The cross slide has two angular contact bearings in here. It's built properly. It has a good feeling to it when you crank it. It doesn't. Some cheaper lathe only have two axial bearings in here and no radial bearing. Those hand cranked like crap. My old lathe was that design, and I modified it for a double row single piece angular contact bearing, which improved it by a lot. Same for the bed slide control. Very little backlash in this crank here. Has a good dial here, which I don't need because I use the DRO. All the dials are nicely engraved, but with the DRO that's obsolete. It also came with this cover over. This chuck cover. Don't laugh. Sometimes you have something chucked in a 6-jaw or 3-jaw chuck, and you're boring it out, and all the chips come out between the chuck and the part and fling out with 500 miles an hour right into your face. And then a chip shield is quite a good idea. It's quite annoying to get chips in the face all the time. But yeah, that's the rough overview of this machine. Emco is an Austrian company. They are still around. I think they changed their name and organization a few times, but they are still around. They are building manual mills and lathes, and CNC mills, vertical machining centers, and CNC lathes. This is right at the edge between an industrial lathe, small industrial machine, and a very high-end hobby machine. It's a little bit of a weird machine. You see them here a lot in maintenance shop and prototype shops and stuff like that. So I thought this machine is a good fit for me. Especially I wanted a machine that can take collets in the spindle. It has a 26mm spindle bore, which is also nice compared to the 20mm my old machine had. There is also a version of this lathe which has a cam lock 4, more stepper 5 inside, and a 36mm bore. Same machine, just different headstock. Those are quite rare here, but it seems like that's the standard which was sold in the US. But here you can get only the Super 11 CD, which is an updated form factor with rounded edges and stuff like that with cam lock 4. It looks ugly, but ugly, that machine. So I wanted this one with the compromise of the slightly smaller spindle bore. This is the draw tube for the collets. It's an aluminium casting that I machined for the handle here. DOM tubing here, and a threaded adapter for the S20x2 threads of the decal collets. The decal collets have a buttress thread on the back side, and this screws together like this. Of course, with the reducing sleeve on the inside. This threaded coupler is just TIG welded onto the end of the DOM tubing, and I'm quite proud of this TIG weld. I think that's the best weld I have ever done. And as you can see, the 125mm 6 jaw is a good fit for the size of the machine. Of course, it overhangs a little bit more than the 3 jaw, but in my experience this was never a problem on my older machine, and as the headstock on this machine is way more rigid, I don't expect any problems here. Of course, I can still use my 5C collet chuck. I bored out the back plate to have the correct taper here to match the spindle. Fortunately enough, the bolt hole pattern here matched the spindle already. Sometimes even I get lucky. Usually when I do something like that, the old bolt circle will be off by 1mm and nothing will fit. But that way it worked out quite well. Okay, I want to quickly go over the old brochure for this machine, for the Maximat Super 11. Here you can see the machine at its full decked out version. Basic lathe, milling attachment, it's sitting on the maker's stand, and it has the rear splash wall to contain the chips. Yeah, here is another view, and here you also can see the full stand. It's relatively nicely built. It's built so you can use coolant, and it's made of heavy sheet metal. It's bolted together from 3 separate box shapes, and yeah, here is the same machine without the milling attachment. Here they go into some construction details like the headstock, the drivetrain with the motor, the pulley V-belt here going up to the main gearbox of the spindle, and here are the change gears that go down to the feed gearbox. There's the feed gearbox with the lead screw and the power shaft for the carriage feed. Tailstock. Tailstock is nothing special. Can be set over for taper turning. Has a large handle here that somebody cut off on my lathe. Yeah, nothing special on the tailstock. Carriage with the power feed lever here, and with the half nut lever here. Electric equipment. Milling attachment. Milling attachment is very nicely made. It was also available as a separate unit with an XY table, so you had a benchtop milling machine with a round column. There are some examples of using the lathe, like ID turning with a steady rest, using the rubber flex collet chuck that's mounted to the front of the spindle to do some turning operation. These chucks show up from time to time on eBay, but they are relatively expensive, so probably not an option for me. And on here there are some operations with the milling attachment. Interesting, I find this one here, number 18, with the head tilted at 90 degrees, using it as a horizontal boring machine. Or here, also with the head tilted 90 degrees, with a slitting saw, also using it as a horizontal machine. Here are a different version. This is the most basic setup. It's just the lathe without anything. benchtop machine. And yeah, you just place it on the bench and we're ready to go. Then you could get it with milling attachment, with the stand, with the splash shield in back, and yeah, build your machine like you wanted it to be, or what you could afford. Back in the day, this machine was really expensive. Some quality inspection stuff, some safety. Here they show some of the parts that are hidden in the drivetrain. This in the center is the main spindle with the large tapered roller bearings, P6 bearings, precision bearings. All the gears are hardened and ground. Same for the spindle itself. The spindle is all hardened and ground. I was quite surprised to see that. On the import lathes, the spindle is usually soft. So that's very nice. I was very happy to see that. And here are the accessories, the coolant system, and the taper attachment. This mounts to the back of the lathe and allows you to turn long tapers, relatively long, maximum taper length 210 millimeters, plus minus 9 degrees taper angle. But these are really rare. You don't see them very much. More accessories, chucks, the lathe cam with a 3-jaw chuck, and there are some other options, but I prefer my own chucks. Quick change tool post. Here is the Rebel Flex collar chuck. Can hold from 4 to 20 millimeters. Cutting tools, accessories for the milling attachment, more cutting tools. And here you have a see-through view of the drivetrain of the machine. Starting here at the headstock with the motor down here, going down to the feed gearbox, going from the feed gearbox with the lead screw up here and the power shaft down here into the carriage. Carriage has, of course, the half nut somewhere in here and the power feed, which also can do power cross feed. So yeah, that's Emco. Still around building CNC machines, vertical machining centers, lathes, manual mills. Okay, I hope you enjoyed this rundown over this machine. Thank you all for watching and see you next time.